The basic principle of block diagram reduction is to simplify the topology while maintaining exactly the same relationships among the variables. So the block diagram reduction is a pictorial way to solve the algebraic equations by eliminating variables. You can compare the block diagram reduction and the one by solving a set of equations algebraically by using Cramer's rule. So in general, the block diagram reduction is easier and more informative. I can't emphasize enough about the importance of the block diagram reduction. The importance is for almost every questions in your second midterm exam and the final exam. You need to get the transfer function from the input to the output by using the block diagram reduction. So here I will give you several examples. Then I would like to work it by your own. Then doing our hybrid teaching mode. So I will teach you how to solve the problem. But before that, I want you to work it by your own and to see where you have trouble to get the transfer function. In this way, I think it will be more efficient for your learning. The first example is a block diagram of a second order system. We have the input R, then two blocks 2, 4 over S, a summing point, then another block 1 over S. This is negative feedback. Please get the transfer function from R to Y. This is the first example. Now let's look at the second example for block diagram simplification. Input R, output is Y. In the forward loop, we have a feedback loop. G1 and G3 are connected in a feedback arrangement. Then the output is connected to both G2 and G6. There another feedback loop. Then we have G5, the sum of the output of G5 and G6. The output is Y. I would like you to get the transfer function from R to Y. This is the second example. This is the third example, block diagram reduction. Input R, then block G1 this symbol, it is also a summing point. So you may see different symbols about the summing point. Whenever you see the plus sign and minus sign, so it will be a summing point. Then another summing point, the third summing point. Then we have two blocks, G2, G3. The output is CS. First feedback loop, H1S. Second feedback loop, H2S. Third feedback loop, H4S. I want you to get the transfer function from RS to CS. This is the third example. Another example, how the input is YS. Sorry, the input is US. The output is YS. Summing point, the integrator 1 over S. A feedback loop with the gain minus A1. Another integrator with the gain minus A2. Another integrator with a gain minus A3. Then we have block B1, block B2, block B3. The output of them summed together to get the output YS. Then I'd like you to get the transfer function from US to YS. This is the fourth example. This is a complex example. I just show you the answer here. But the question is, for this complex block diagram, there almost no way you can use block diagram reduction to simplify this block diagram. I will tell you why. Why we cannot do it. The reason is we learn the block diagram algebra by moving the pick-off point and the block. We also learn how to move the summer and the block. But I have never teach you how to move the pick-off point and the summer. In other words, there are no rules to change the positions of the pick-off point and the summer. Then here you can't apply the feedback rule, because feedback rule means the input to the output. So you have a pick-off point here. So you cannot exchange the provision, the pick-off point, and the summer. The same here, you can't apply the feedback rule here because you can't change the position of the pick-off point and the summer. Same here, the same here. Same for this parallel connection. So then how to get the transfer function in this case? Then we have to go back to the algebra approach. Then we have input u and output y. Then let's denote the output at this point for maybe as y1. Then you know this is a pick-off point. Then the output here is h5 times y1. Then here is u plus h5 times y1. Then at this point is h1 times u plus h5 times y1. Then u plus h5 times y1 plus h4 here. Here is u plus h5 y1. And here it's multiplied by h1. So here multiplied by h4 u plus h5 y1. And here you have h2 y1. Then you feed back this loop of h7 h4. Then u plus h5 y1. Then here is the sum of h2 y1 plus h7 h4. Then u plus h5 y1. Then it times h3 and sums together is h4 u is the y. Then you also need this one to feed back here. You know y1 is the output, and sum of output h4 and sum of output h1. Then using the algebraic relationship by eliminating h1, sorry, it's y1. By eliminating y1, then you can get the transfer function from y from U to Y. So the last example I showed you is a very complex example. So this question is last year's final exam question. So you need to be able to obtain the transfer function in this typical level. Have the input and output with a few blocks in the feedback arrangement. Then they are connected in series and also feedback loop. So please work on these questions. Then we will discuss them on Wednesday and Friday.